Hi everyone, so thanks for joining me as we are going to graph cube and square root functions together. So we're going to start our first function, f of x is equal to the square root of x. We're going to make a table first, and we picked some x values, and then we took those x values and we plugged it into the x into our function, and we got, as a result, we got our y value. So we're going to go ahead and plot those points on our graph. And then we're going to connect them together. Now, there's a reason why we actually picked those specific x values, and the reason being these are perfect squares. Now, we picked those x values because if I put 2 in for x, I'm actually not going to get a whole number. So to make my life a little bit easier and yours, we pick perfect squares. We're going to get nice whole numbers as a y value, and then our ordered pairs are going to be easier for us to go ahead and plot. Now we look at our domain. I've got the smallest x being 0 going all the way towards positive infinity. And then my range, again, smallest y value is 0 going all the way to infinity. So this is actually going to be what's called our parent function. It's our original function, and it's just the square root of x. Now we're going to look at examples with transformations. So now we're going to go ahead and take our parent function, which is y is equal to the square root of x, and we're going to go ahead and do some transformations on them. So right now what I'm going to do is I'm going to make my general table, which I made in the previous slide. I had 0, 0, 1, 1, 4, 2, 9, 3, and then 16, 4. Again, those were my x's with the perfect squares. And I'm going to look at each transformation first. I have a plus 5 underneath the radical, and then I have that plus 2. Now each of these are going to go ahead and mean something else. Now the plus 5 is actually going to be a transformation on your x, which is actually opposite. So inside's opposite, so it's actually going to be a minus 5, so going to the left 5. And then the plus 2 is actually going to be a transformation on your y values, so that's going up 2. So to the original table that I had right over here, for my x column, I'm going to go ahead and do that x minus 5 transformation. So all those x values, I'm going to subtract 5 to them. And then all my y values, because I have a transformation on my y, which was the up 2, so plus 2, I'm going to go ahead and add 2. Well, once I make my new table, I've now gone ahead and seeing that I have a new table of values. So I can go ahead and plot those points. Make my curve. Again, it should look pretty similar to the previous example. Your parent function is going to look almost like a half a u, a half parabola. Now, if I look at my domain, I got my smallest x value, which was negative 5, going all the way towards positive infinity. And my range is going to be smallest y value of 2, and then going all the way towards positive infinity. Okay, in this example, what we're going to do is we're going to give you a graph, and then we're going to ask you to find the actual equation. So the first thing you want to do is look. I do have a square root function, looks like kind of a half of a parabola here. And for right now, I'm going to go ahead and graph my parent function. So that was 0, 0, 1, 1, and then that 4, 2. So that's my parent function. So I know this is going to have a square root of x. So now I can see I actually have a reflection over the x-axis because my graph actually flipped upside down. So what I'm going to do is I'm going to go ahead and plot those points. So those y values would have flipped down. And a reflection over the x-axis is going to be that little negative that's in front on the outside. Now that we have our graph flipped upside down, I can kind of look and see, all right, well, this point right here, this 0, 0 point, has to move over in the left direction and then it has to move up in order for that graph to almost be identical. So what I can see is I'm actually going to move left 5. So I'm going to take all my points and I'm going to shift them over left 5. And doing that left 5, I'm going to go ahead and see, well, left 5. Left, I know is going to be underneath that radical, so it's opposite. So it looks like it should be a plus 5, so it's opposite. So x plus 5. And then I have to go up. So I'm going to have to move everything up 2 spaces. So I'm going to go ahead and plot each of those points up 2 spaces. And then what you should see is that when I make my up 2, that plus 2 is going to be on the outside of my radical as part of my equation. So now you can go ahead and see after each of those transformations, I've actually overlapped and I've ended up right on top of the equation that I was given. So now my domain, I'm looking at -5 going all the way towards positive infinity. And my range is actually going to be from the smallest y, so -infinity, going all the way up to positive 2. Okay, here is our cube root function. I got a little cube root, so I'm going to go ahead and I'm going to graph my original table. All right, so I got -8, 2. I've got -1, 1, 0, 0, 1, 1, and then 8, 2. Now again, just like my square root function, there was a reason as to why I picked those particular values for x. These are all your perfect cubes. Now again, just like your square root function, if you've got perfect cubes underneath a cube root, getting each of these y values and getting nice whole numbers is going to make it easier for you to go ahead and plot those points. Now look at your domain. We got -infinity all the way towards positive infinity, and it's likely also the same for my range. Now we're going to go ahead and do some transformations on my parent function, my cube root function. And here right now in the very beginning, what I have is my original, my parent function table. And I'm going to do a transformation on there too. I've got that negative as well as that 3. Now because both of those are on the outside, those are both going to be a transformation on my y. So notice that my x all stays the same, but then my y, I'm going to take it, I'm going to multiply it by a -3. So it's going to be a reflection as well as a vertical stretch, so making my graph look a little taller. So when I graph these points, and I connect my dots together, okay, you're going to go ahead and see that I've got still kind of like a curve, but now it's just flipped around the other way. My domain, again, all real numbers, -infinity to positive infinity, as well as for my range, -infinity to positive infinity. Okay, here you are given a picture of a graph, and it does look kind of like a curve, like an S. So it's not like my square root function. This is my cube root function. So I first want to go ahead and see what is my parent function. Let's graph that on there. So I got -8, 2, -1, 1, 0, 0, 1, 1, and then I'll get that 8, 2 a little bit off of my graph here. So here is my parent function. All right, so what I want to do is, because we actually give you these 2 coordinates here, this is kind of the middle and the other point. So that's these 2 points right here that I'm going to be looking at. I want to see, how do I get these 2 points to match up to these 2 points? Okay, so the first thing you should see is I actually have to do a vertical stretch. Now, a vertical stretch is to make my graph look taller. So what I'm doing is I'm actually going to be multiplying my y values by 2. So it's gone from having a little space between 1, -1 and 1 and 0, 0, and then gone from this y value and making it a little bit taller to get to -6. Now remember, I'm not adding 2. Adding would be shifting. I'm going to multiply and stretch it out. So that vertical stretch by 2 is taking each of those y values from my parent function, multiplying those y values by 2, so that way I can make, again, stretching it out along the y's. So that vertical stretch by 2 is going to give me that 2 that's in front of my radical. So now what I'm going to do is I'm actually going to shift my equation to the left 1. So take each of those x's, now not the y's, my x's, and I'm going to go ahead and move each of those x's to the left 1 space. Shifting to the left or the right is a transformation underneath my radical, but it's an opposite of what we think is actually going to be the sign. So it's going to be a +1. And now we're getting closer. As you notice, these 2 points are matching up pretty close to these 2 points that were given, but now I just have to be shifting down 4. So again, we're going to take these values and we're shifting each of those y values now down 4, and you notice that they will actually match up perfectly to the function that you were given. Now that down 4 again, it's going to be on the outside, so that's going to be that -4 on the outside. Domain and range, you guessed it, has been consistently negative infinity to positive infinity, all real numbers. Now here are some things for you to remember. The x values for the square root function are going to be perfect squares, and the x values for the cube root function are going to be perfect cubes. So when you make your table for the original, the parent function, it's a good idea to have those first couple perfect cubes and perfect squares memorized. Now I hope this video was helpful and you're able to graph square root and cube root functions and also identify the domain and range, especially when we do transformations. Thanks for watching and have a great day.